Okay, welcome back. So today, this is going to be a really short lesson. We're just going to talk about different methods of regression and how to compare them. We're going to be using what's called the R-squared value. So I have a table over here, and I just made the numbers up, so these aren't real ones like they have been for a while. So we're going to say the X value here represents days. And let's say the Y value represents, I don't know, an amount of anger Mr. Taft has expressed as a percentage. 0 days into the school year, I have 20% anger. Day 25, 232, 349, 460, 575. And we want to create an equation to express this. So we have a few different options. First, we can make a linear regression. So to do that, I'm going to do y sub 1 approximately mx sub 1 plus b. I'm going to adjust my my window over here. So my x values need to go between 0 and my y values need to go between 0 and let's do 100. There we go. Now the r-squared value here is 0.9699, and that is roughly a percentage of how closely it matches the graph. It means something quite a little bit more than that, but we're going to call it that. I could also come up with a quadratic model. The quadratic model would be y sub 1 approximately ax sub 1 squared plus bx sub 1 c. And you can see that this fits it not quite as well, or this fits it better, 0.99, because there's a bit of a curve to it, and the line doesn't take the curve into account. And the last one that we can use is an exponential model. And the exponential model I'm going to use here is sub 1 approximately a x sub power. And this has a really bad r-squared model. Add to make this a, to make this b. There we go. So we have our principal value. B would be everything that's inside the parentheses, and then c is some third value that's multiplying by the exponent. And this would be 0.99. Now, comparing these three models, you can see that definitely the quadratic or the exponential fit better. And their r-squared values are closer to 1. The closer an r-squared value is to 1, the better the regression is. Let's add another couple values here. Let's say 6 goes to 92, and let's say 7 goes to 1. And now you can see that quadratic is still better than exponential, but not really that much more. And they're definitely both better than linear still. Better. Okay, so this part of your book assignment is comparing different models. So you'll be given a table of information. You'll be asked to find what model fits it best and then give that model. And in general, these are the kind of the blank ones that you should use. Is y sub 1 about mx sub 1 plus b. Quadratic would be ax sub 1 squared plus bx sub 1 plus c. And then exponential should be ab to the power of cx sub 1. Okay, cool. You could break this exponential model down further if you wanted to. So you could use like exactly the nomenclature that we used in class. So you could do p times plus rate, close parentheses, like that. But it doesn't make the model any better in this case. But if that helps you, you can then find out what the principal, the rate, and then what number is being multiplied by x. And in the case of exponential decay, the c would be less than 1. So it would be, like 1/2. Okay, told you this was going to be a fast one. That should cover pretty much everything that's in your book assignment. There's one other kind of problem that will show up on the quiz, and let's talk about that right now. So the other problem that'll show up on the quiz would be something like, I don't want to give you the exact problem, so let's do something similar. Say 3 to the 5x and you need to solve for x. What you want to do first is focus on, actually this shouldn't be plus, it should be times. You want to focus on getting these to have the same base, because if you're multiplying two things with the same base, like say x squared times third, if the base is the same, then the exponents add 2 plus 3, which is 5. So here you want to transform either 3 to be in terms of 9 or 9 to be in terms of 3. In this case, I'm going to do 9 to be in terms of 3. So 5x times 9 is 3 squared to the 2x, 20. And when you raise a power to a power, so x squared to the third, these get multiplied. This becomes x to the 6th. So this is 3 to the 5x times 3 to the 4x, 20. These are multiplying, which means that the powers add. So this is going to be 3. And now you can use a logarithm. So you can say log base 3 of 20 is equal to 9x. The cat's over there messing with stuff. And you can evaluate this and then divide by 9. There's something really similar to this on quiz for this week that's taken directly from an ACT prep course. So that's it. That should cover pretty much everything. If there's anything on Unit 1, Section 3 I didn't cover, please let me know and we'll go over it together. I'm going to go see what my cat has gotten into, and I hope you guys have a wonderful day.